Welcome. Today's notes worksheet is entitled Algebraic Skills Revisited. This lesson just offers us an opportunity to review and solidify some of the real comprehensive skills that we've been working on all unit long here. Some good difficult problems that we'll look at, and it's just a matter of getting more practice with it. So let's go ahead and do it. See how your comfort level is with each piece. And if you're feeling good about certain skill sets, great. If you're lacking on certain skill sets, those are the ones obviously you'd want to focus on. So let's go for it. Let's kind of start out this piece right here, factoring. So I think we had at least 6 or 7 patterns to look for. This one in particular seems to be a quadratic trinomial as I look at example 1a. Remember, of course, you're always looking to do greatest common factor first. I don't see a greatest common factor here, unfortunately. And so what we're going to do is reverse FOIL this or anti-FOIL this, whatever we want to call it. We can use my method, or we can, try something else. It's up to you. But basically, let's see if we can factor this. So I'm going to go through my method one time. I would myself, if I was to do this one, probably do a little trial and error. But in this case, I think I'll go ahead and just do my method. So here we go. Bring over the 8. Sometimes, seeing it after not having seen it for a little bit really solidifies that idea. So 8 times 15, I'm getting $1.20 on that, and that's looking pretty good. So just changing it momentarily. And of course, let's bring that in. X and X. Now here's a good one. I need 2 numbers that multiply to negative 120 and add to negative 19. Yikes. So there's so many numbers that go into 120 there. I got it. I've got a minus 24 and a plus 5. So, that obviously in this case makes it more difficult, but you would have to be able to do that piece. Well, regardless, I think that's our combo right there. Notice I left some room out in front to tuck the 8 back in. So the 8 goes back in. And remember, I overcompensate. Somewhere there's an extra 8 embedded in these 2 factors. Let's go get rid of it. So I think it's all right here, because 8 goes into both of those. And there is that quadratic trinomial factored. Cool. So again, just the method. As I said, I would probably go trial and error on that, work through some of the factors of 8, work through some of the factors of 15, and just kind of play around with it and get that at the end. Okay, good. 4-term cubic, really only method that I know that's going to go with this, if possible at this stage, traditional method I should say, is going to be grouping. So let's go ahead and make this happen. Let's group those and think about the 6 and 9, think about the x cubed and x squared. We do want to go GCF on this. And so we should really be in a good state with this, be able to pull these off. So I'm seeing a 2x minus 3 right there. That looks good. Now this one, again, at first glance, doesn't look like it has a GCF. I mean, it does. We just typically don't think of it like that. But I do want to pull out the 1 here. I think it just works much better visually, because now, guys, I have my 2 terms separated by that plus, and in each of those 2 terms is a 2x minus 3. So I'm going to pull out that 2x minus 3. When I pull out 2x minus 3 from here, I get 3x squared. Here's my plus. When I pull out my 2x minus 3 from here, there I get that 1. Always look to go further. Linear factor, it's quadratic, but really nothing I can do with it. And so as a result, there you go. All right, so we've had a quadratic trinomial, quite a difficult one as a matter of fact. A 4-term cubic, grouped nicely. Let's go get this one. So think about which pattern would work here. And, I see a couple things. Initially, always looking for a greatest common factor. I'm going to pull out the 4 and get that right there. That's interesting. So the 4 came out nicely. And then I'm looking at this x to the 8th. We kind of developed this idea not too long ago. And the minus the 4, that definitely is a pattern that we've seen in terms of it being a difference of 2 squares. because I've got something times itself that'll give me x to the 8th. Remember, it's x to the 4th and x to the 4th. So when I multiply powers of the same base, remember, add the exponents. So 4 plus 4 is what gives me the 8. And I'm getting a 2 and a 2 right there. And again, 1 plus, 1 minus. And I don't know. I don't think I'd go much further on that. Obviously, if we were solving equations and doing some other stuff. But in this case, just as a factored expression, I think that should suffice. Okay, so seeing a couple difference of 2 squareds come out and a greatest common factor. I like it. All right, so just, again, experience and practice with each of these skill sets. So skill set number 1, factoring. Check it off. Let's go get skill set number 2, working with rational expressions, particularly addition and subtraction. And even being more particular, I've seen many more mistakes with subtraction than I have with addition. And it's just based on the calculations that are required. So let's go for it. LCD. I'm going to write it up to the side right here. I'm getting an LCD of x minus 1, x plus 2. And I hope you are as well. So I'm going to go ahead and begin the madness right down here. 1 big fraction. Yikes. But there's my LCD. So notice what I did here is I changed each of the individual fractions. I changed each of the denominators from old to new and improved. How did I do that? Well, however I did that is how I have to compensate on the numerator. So we had x plus 1 on the numerator. That's going to have to change. So let's go for it. Here we go. Look at the denominators. Be very careful with it. So x minus 1 originally, now x minus 1 times x plus 2. So you know I multiplied by x plus 2. If I multiply the denominator by x plus 2, then I have to multiply the numerator by x plus 2. Okay, very nice. Minus right there. Now let's look at the right fraction, specifically the denominator. Old, new, and improved. And notice it changed by multiplying the old one by x minus 1. So if I multiply the denominator by x minus 1, then I have to multiply the numerator, of course, by x minus 1. All right, now I hope that looks good. If you can get to that stage, that's great. That's where the concept lies. Now it's just playing cleanup from here. Denominator is good. Remember, we can't really do anything. I'm not canceling. That doesn't make sense here. I'm cleaning up the numerator, and that's it. Multiplication comes before subtraction. So let's FOIL and then see where we're at. I'll multiply these two together, everybody, and I get x squared plus 3x plus 2. Now minus, now again, just careful on the back. That's the key. So when I multiply on the back side there, I get x squared minus 3x and plus 2. Now, if you can do this while it's in parentheses, that's great. If you can't, then what I would do is distribute that minus in and change all the signs. So I'm hoping you see x squared minus x squared cancels. 3x minus negative 3x is 6x. And 2 minus 2 cancels, really. So again, I do this like this. I just make sure that I minus, and it's each and every one of those terms, and I hope you will as well. Because when you do that, wow, this worked out really nicely, huh? Just 6x over x minus 1, x plus 2. And I think that's your winner. Okay, good. So just adding and subtracting rational expressions. Remember, get a common denominator. However you change one denominator, you've got to change that numerator as well. The other part that goes into the rational expressions deals with compound or complex fractions, fractions within fractions. So we've kind of cleaned this out a little bit, a couple different ways. I like rewriting it. You don't have to if you don't want to. Again, I'm just a very visual person, and it helps me get a little symmetry in there. Something like this. You know, officially, there are 4 fractions within the overall fraction. And I want to clean out all of those individual denominators, 1, 2, 3, and 4. The way we did this the shortcut method, so to speak, was to just multiply each of the individual fractions by the least common denominator, which I'm hoping you see is x minus 1. And we've kind of talked about how and why this works, but I would argue 99% of the time it is quite a bit more efficient than the formal approach. And the formal approach would be, of course, adding two fractions together, subtracting two fractions together, and then doing the big division symbol at the end. To me, too many steps. But, you know, to each his own. So what we do is we just distribute, in this case, 1, 2, 3, 4 times. If you need to work off to the side, please do so. But we've kind of already looked at this in a little more detail than the way I'm going to play it here. When I distribute it in here, the whole point is to get rid of that x minus 1. So these would cancel, and I get 5x. I'm going to bring it right over here. Okay, over here is the plus. Now I distribute it into the 2 over the 1. So it doesn't matter since it's over 1, but I just distribute it into the 2, and I get 2 times x minus 1. If it's okay with you, I'm just going to do 2x minus 2. Now, 2 down, 2 to go. Distribute it in here. This doesn't cancel with anything, so I just distribute it in. 3 times x minus 1 is 3x minus 3. Then a minus. Distribute it one last time, and here is where I wanted this x minus 1 to cancel. That had to go, and now it will. This cancels out with this, and I'm left with the 4. And let's just clean it up. 5x plus 2x is 7x minus the 2. Down on the bottom, 3x minus 3 minus 4 gives me minus 7. And that's looking good. Not too bad. Let's try one more. As you look at that piece, just make sure it's all clicking for you. And again, if you need to work off to the side on these when you distribute in, please do so. Okay, I've got x plus 1. I'm going to just go ahead and do this as x minus 2, or x times, excuse me, x minus 2. How about a 2 over x right here? And I'm going to do it as 1 over 1. If you don't like that, by the way, don't bother. You know, I just do it, but there's nothing written in stone that needs to be done. All right, let's get this least common denominator here. I'm seeing it's 4 denominators, 1, 2, 3, and 4. Least common denominator should be x minus 2. Each of these divides evenly into that. All right, so I guess I'll have to go on the right-hand side here. So x minus 2. X minus 2, again, we already explored why and how this plays out. Now we're just applying it. Let's do it. All right, distribute. 1, 2, 3, 4. Here we go. 1, 2, 3, and 4. So when we do it into this first fraction right here, x's cancel. X minus 2's cancel. And I'm left with x plus 1. Okay, here's my plus right there. Comes down nicely. I don't like that x there. It's got to go. The fractions within fractions have to be eliminated. So now, when I distribute it in, though, the x's cancel, and I'm left with a 2 times x minus 2. So 2x and minus 4. All right. This distributes into the 1. Nothing cancels, so just this times 1. I'm going to now bring it on back. X squared minus 2x. And last but not least, after I put the plus in, let's distribute it in here, guys. Canceling x minus 2's. I have an x left. X minus 3. X times x minus 3 should be that. All right. Well, let's put some things together here. I'm just going to have to come on up here. Hopefully you have a little more room on your sheet. Clean up the numerator. Clean up that denominator. You got it. Here we go. X and 2x. 3x. 1 and negative 4. Beautiful. X squared and x squared. I've got 2 of them. Negative 2x, negative 3x combined to negative 5x. Now here's the thing. That looks great, by the way. I kind of know what you're thinking there. Hey, the top factors, the bottom factors, you can factor it if you want. Really, the rationale for factoring at this stage is to cancel a common factor in the numerator and denominator out. And the factor of 3 and the factor of x don't cancel out. So there's no real purpose, I guess, long story short there. If you did, it's fine. I have no problems with that at all. But that's a good answer right there. I'm going to leave it. And there is example 3 in a nutshell. Compound fractions. Again, just a little more practice on it. I'm hoping it's clicking. Onward. Square roots, radicals. In this case, it looks like there are no square roots there, but all right, let's go radicals. I've got cube root for A, fifth root for B, and some cube roots for C. Okay, sounds good to me. Let's see what we can do. So product property all the way, everyone. What we're going to do is try to pull out the perfect cubes here, keep it in exact form, and remember just kind of our list there. 1 is a perfect cube, although that's irrelevant. 8 is a perfect cube, 27 is a perfect cube, 64 is a perfect cube. You know, and so I'm just trying to find, is there a perfect cube that goes into 162? I can do just a little quick arithmetic there. Let's try it out. Let's try 8. So 162 divided by 8, no luck. So no factor of 8 in 162. How about 27? Ooh, there we go. That might be our winner, 27 and 6. I don't think 64 is going to work, especially because the 8 didn't work. So unfortunately, I think 64 is out. 125, definitely not. So I'm thinking 27 is our key here. So let's do it. 27 and 6 is what I saw. 27 times 6 is 162. So I can write this using the product property as cube root of 27 times cube root of 6. And so cube root of 27 is just 3. So 3 times the cube root of 6. Good simplification there. I like that piece. Good number sense. Really, quite awesome. Let's go into B, getting a little more complicated. Fifth root. So the way I've been doing this is kind of creating our perfect fifths in one radical, and then the leftover factors in the other radical, and then obviously the product property allows us to do that. Now, I'm curious if you happen to see it, but numerically, what do you know about 32? Is there a number raised to the fifth that is 32, or is there a number raised to the fifth that goes into 32? Well, I'm seeing 2, actually. So when all's said and done, guys, 32 is a perfect fifth. I hope that makes sense. And we'll get that taken care of momentarily. Now, guys, let's think about the largest perfect fifth that goes in here. We developed some patterns on this. I'm hoping you would see x to the fifth, y to the fifth, and z to the 10th. All right, those are the perfect fifths that divide evenly into 1, 2, 3 terms right here. Now the leftover, and by the way, I'm going to just change this up a little bit so it doesn't get too convoluted. There we go. So now times the other fifth root. Again, I think I said 32 was a perfect fifth, no leftover factors. I got x to the fifth in here. X to the fifth times x squared would give me x to the 7th. Y to the fifth in here. Y to the fifth times y to the 3rd is y to the 8th. Z to the 10th is in there, so nothing there. And I think we're pretty much ready to roll. These are all perfect fifths. Now what I'm going to do is just apply it. So in this case, the fifth root of 32 is 2. The fifth root of x to the fifth, and this is kind of the whole point, is x. Fifth root of y to the fifth, again, these just cancel out and we get y. And the fifth root of z to the 10th should be z squared. Really cool. Now let's go ahead and multiply that by this piece right here. And I think that's it. Cool. Yeah. Looks great. Wow. Nice. Letter C. Combining roots together. And so here's where we're going to be a little careful. I'll take this in several steps. I don't mind doing that. But basically what I have going is at this stage I can't combine them. Remember, adding and subtracting, they have to be the same root, but they all have to be the same term underneath the root as well. So let's see if we can work this out. Let's break down each of these roots. 8 goes into 16. So as a cube root, 8 is the perfect cube there, I believe. So I'm going to do that for the time being. Let's see, 64 is a great cube root, or a perfect cube, I should say, that goes into 128. Sounds good. And then one more here. Let's see, I have my factor of 6. 27 I'm liking in there. 27 goes in, and 27 goes in 3 times. All right, so finding the perfect cubes that go into each of those terms right there. I've got those. I've applied the product property. Now let's play it out. So this would be 2. This would be 4. And this would be a 3. How's that look so far? Just now reconciling all those perfect cubes that we put underneath the roots there. And I think we're doing pretty well. I've just multiple steps on this one for me, but if you can streamline it, please do so. I've got 10 cube root of 2 there, 16 cube root of 2 there, and I'm getting an 18 cube root of 3 right here. Good. Remember, just think of what you can combine and what you can't. These two can go together. Same root, same term. This one, unfortunately, can't. So I'm just seeing this as -6 cube root of 2 plus 18 cube root of 3. Obviously, guys, if you want to switch the order, which would probably be a little better, but whatever, it is the same. 18 cube root of 3 minus 6 cube root of 2. Identical expression, an identical value to what we started with. All right. We've got them. So roots and radicals, all different properties there. Obviously didn't include all of them, but just some good problems nonetheless. Okay, let's go on to our next and last piece. All right, the big ones here. So dealing with expressions with rational exponents, simplify, and write without negative exponents. Okay. Now A and B are pretty much identical. It's C that's the big one there. But let's start it out. It's all just factoring. So we're going to manipulate this expression. Instead of a difference of 2 terms, what we're going to do is write as a product of all its terms. So let's go for it. 2 terms separated by the minus. Each of those numerically has a 6 that goes into it. So let's pull out a 6. And then we've talked about this before. 2 powers with the same base. Its greatest common factor is very simply the lower of the 2. And y to the -5/3 would be a lower power than y to the -2/3. Now I'll go ahead and do this off to the side like I did before. If we're not sure what goes inside, I take the original and divide by what I pulled out. That was our key. So this is good to do just thinking about these pieces. 12 divided by 6 is 2. This divided by itself is 1, so I get 2. Minus, and then let's go ahead and play that out again. I have 18 y to the -2/3, and let's see, 6 y to the -5/3. Let's see it play out nicely. 18 divided by 6 is 3, and divide those powers with the same base, keep that base, subtract those exponents. -2/3 minus -5/3 is 3/3. So it's y to the first, which of course is just y. Looks good. I'd probably play around with it just a little bit more. Remember just that negative exponent on that y to the -5/3 there. So what do you say we bring that on down? And that's a great answer. Looks good. Very clean, very simplified. All right, 5A in the books. Factored. Let's see if we can repeat the process on 5B. Always, please feel free. Pause, fast forward, rewind, whatever you need to do. See if you can pull it off on your own. That's the idea, especially with this notes worksheet. All right, greatest common factor. I'm seeing it as just that x minus 1 raised to the -3/4. Yikes. Not a great one by any means, but well, let's see. Let's see if we can do this without kind of working off to the side. So this is what I pulled out of each term. I pull it out of here, so now it's gone by the way, and I'm just left with x. Cool. I'm going to pull it out of here. So this divided by this should tell me what goes here. So again, when I divide, I keep the base, and I subtract the exponents, and I'm hoping you see, like you have seen before, subtracting the exponents really gives me 4 over 4, which is 1, so it's really just x minus 1 to the first, or x minus 1. Let's clean it up a little bit. I'll do it in 2 steps here. Inside, I'm getting a 2x minus 1. And now, guys, this times this looks great. I personally like it just better expressed, separated, numerator, denominator. Different parts work algebraically with different concepts. So here's our numerator, and there's our denominator. And again, pretty nice. Okay, last one. So letter C. This kind of fell under the category of a single quotient, which it is, but we would simplify by seeing what we can factor and work with. So let's do that. Numerator is really what I'm focused on here, and I'm hoping you would look at that as well. Again, I can see a couple ways to do this problem, by the way. So if you see an alternative approach, run it by me, and be curious to see if we could all kind of get to the same position. I like this. I like factoring. I think it's a great skill set, and it works nicely in this context. So that's how I'm going to play it. But basically, let's factor that numerator. And I'm going to pull out an x squared plus 4 to the negative 1/2. When I do that in the numerator, this divided by this is x squared plus 4 to the first, or just x squared plus 4. And then plus, in this case, this divided by this is just 1. Cool. And then x squared plus 4, just because it's the same power as what I see up here, I'm going to go ahead and just put that exponent with it. Maybe it just helps stimulate an idea. All right, now where do we go from here? Number 1, clean up the remaining factor. Whatever like terms we can put together, we will. And then do you want to divide 2 powers with the same base? I think we can do that. So let's divide 2 powers with the same base here. I keep the base, and I do subtract those exponents. Negative 1/2 minus 1. And that should be negative 3/2 there. And then this right here should be x squared plus 5. Take a look at that. Make sure that works for you. Divide powers with the same base, keep the base, and subtract those exponents. And now it's looking great. It's a product, but I like that negative exponent being moved. Make it positive, and there we go. Okay, again, different approaches. So if you thought of something else there, that's fine. No problems at all. But I think that's probably where we wanted it to get to. All right, so again, this this notes worksheet was just meant to solidify some of the really comprehensive skills that we've been developing over this unit. So hopefully it just helps. And then obviously you're just getting practice, you're asking questions, you're getting support, and you're collaborating and doing all the stuff you need to do to be successful. Let me know how I can help with that process, of course. Why don't we wrap it up at this stage? Please just let me know if you have any questions. Thank you so much for listening.